Let's talk about something pretty wild. What if the next big leap in AI doesn't come from a new algorithm, but from cleaning up its diet? Today, we're diving into some incredible new research that's smashing together artificial intelligence and quantum computing to solve one of AI's oldest, dirtiest secrets: bad data. But before we even get to the quantum stuff, let's start with a really fundamental question. We're betting our future on AI, right? But what if the very foundation it's built on is cracked? What if the data we're feeding it is just full of lies? We're talking about errors, mistakes, what researchers call mislabeled instances. And this isn't just some small technical bug, it's a huge problem that could totally undermine our trust in these systems. And yeah, that brings us right to the heart of the matter, the big challenge this new research is tackling head-on, the AI's dirty data problem. So what exactly is dirty data? Well, at its core, we're talking about simple mistakes. A mislabeled instance is exactly what it sounds like. It's a picture of a cat that somehow got labeled dog, or maybe a medical scan that was misinterpreted. These little errors might seem harmless, but when you have millions of them in the giant data sets that train our AI, the consequences can be huge. You know, it really all boils down to that classic saying from the early days of computing: garbage in, garbage out. It's just common sense, right? If you feed an AI a ton of junk data, you just can't expect it to give you brilliant, accurate answers. The research is super clear on this. These errors can absolutely cripple an AI's performance. So the big question is, how do we take out the trash? All right, so how do we fix this? I mean, how can we possibly clean up these massive, massive data sets in an efficient way? Well, this is where the new research comes in. It proposes a really innovative solution, one that's kind of like a new kind of data detective. So forget trying to have a person sift through billions of data points. That's impossible. This new method is basically a super smart algorithm that acts as a data detective. It's incredibly good at spotting the bad apples, the fakes, the mistakes in a data set, and just tossing them out, leaving only the good, clean data behind. Okay, so how does this detective actually do its job? Well, it's a really clever loop. First, it just takes a guess at what a clean version of the data set might look like. Then it trains a temporary, kind of quick and dirty AI on that guess. And it tests how well that AI does against a small, totally perfect, trusted set of data. Step 3, based on how well it did, it makes a smarter guess about which data points are good and which are bad. And then it just repeats that whole cycle over and over, getting closer and closer to a perfectly clean data set every single time. So that's the theory, and it sounds great, but you have to prove it, right? To do that, the researchers set up a proving ground. They designed this perfectly controlled experiment to put their data detective through the ultimate test. They built this custom challenge called the noisy majority bit task. Now, just imagine an AI is looking at a string of 9 digits, just zeros and ones, and all it has to do is guess which one appears more often. It's a really simple task on purpose. That makes it the perfect hiding place for fake data, to see if our detective can actually sniff it out. And they did not mess around. They created a data set that was literally 50% poison. Half the data was correct, and the other half was intentionally, completely wrong. An AI trained on this would be totally lost. It would basically just be guessing. So the goal was crystal clear. Could this algorithm, this data detective, figure out which 64 data points were the real ones and which 64 were the fakes? Could it effectively clean the data set so that a useful AI could actually learn from it? And now we get to the main event. This is where it gets really cool. The researchers took 3 different versions of their data detective and pitted them against each other. 2 of them were running on regular classical computers, but the third one had a secret weapon, a D-wave quantum annealer. The results, well, they were a total knockout. This chart here shows the loss for each method. You can just think of loss as an error score. The lower the score, the better the job it did, the cleaner the data. And as you can see, the classical methods, they did okay. But the D-wave quantum annealer consistently found the best solution. It delivered the cleanest data with the lowest error score every time. But here's the kicker. The quantum computer wasn't just more accurate, it was unbelievably fast. We're talking over 100 times faster than one of the classical methods. To put that into perspective, that's like one detective solving a crime in an hour while the other detective takes more than 4 days. This, right here, is the quantum advantage in action. So, why?
Why is it so much better? Well, it really comes down to their whole approach. The classical methods are kind of like a detective who finds one good clue and then gets obsessed with it, just generating a lot of redundant, similar ideas. But the D-Wave quantum annealer, it's like a whole team of detectives, all exploring many different, diverse, high-quality possibilities at the exact same time. The secret sauce, as the paper calls it, is sample diversity. Because of a bizarre quantum effect called tunneling, the quantum computer can essentially cheat. It can find shortcuts through problems that would completely stop a normal computer. This lets it explore a way bigger range of possible solutions and find the absolute best one, not just a good enough one. Okay, so let's recap. We have a quantum-powered data detective that is both faster and more accurate than its classical competition. That's awesome. But what does it mean for the big picture? Why does this really matter?
Well, one of the most fascinating things they discovered is that this algorithm isn't just a brute force filter, it's actually intelligent. The research showed that it prioritizes removing the most harmful, the most damaging mistakes first, which makes the whole cleaning process incredibly efficient.
So what makes a mistake high risk? Well, think of it like this. If you show a kid a picture of 9 apples and you tell them, that's 1 banana, that's a high-risk mistake. It's so obviously and fundamentally wrong, it's more confusing than showing them a picture with maybe 4 apples and 5 bananas. The quantum data detective is smart enough to spot those really blatant, confusing contradictions and just get rid of them right away. And when you start thinking about that, the potential here is just staggering. We're not just talking about a slightly better AI. We're talking about a future where medical diagnoses could be more accurate, where financial markets are more stable, where self-driving cars are safer, all because the AI that they depend on is learning from pristine, quantum-cleaned data. This really could be a whole new chapter for AI. And hey, don't just take my word for it. Let's look at the researchers' own words from the paper's conclusion. Quantum annealing is particularly well-suited for subset selection tasks in machine learning. What that means is this isn't just some one-off trick. It points to a fundamental strength of this technology for solving this very specific but very critical problem in AI. Which kind of leaves us with this final massive question. We're always talking about better algorithms or more powerful chips being the key to the future of AI. But maybe, just maybe, we've been overlooking something just as important: the data itself. Could creating these perfectly clean datasets with the help of quantum computers, could that be the real key to unlocking the next level of artificial intelligence?